Assalamu alaikum.
Welcome, someone.
How are you?
Confused.
Confused with what?
Why do people go to cafes at 7 in the morning?
7 in the morning.
Yes, I
It's
walked in and there was already three, four tables like filled with people, and I'm like,
oh
what is
my
going
God.
on? People here are weird. It's okay.
It's
It's okay.
Saturday, right? I think maybe people go into work and then maybe they think of grabbing
Or
some coffee or something.
yeah, but leave me alone, please. That's all right.
Uh,
It's all right.
okay, all right,
But it's okay. I got a Lego set, so we're
okay,
good. We're happy.
okay, 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 all right.
Anyways, anyways,
All right, so we were discussing dot products and scale, or scalar products the previous day, and let's try to move into
yes,
vector products. And now, one thing we had a question in the previous day, that is, if the projection of vector P was projection of vector P on Q was let me 1 second, just where was the other PDF? Just a second. If I show this one to you, okay, all right. So if the projection of B on A was B cosine theta, then our question was, why is the projection of P on Q uh like Q cosine theta? Yes. Why is the projection of P on Q cosine theta? It should have been P cosine theta. Okay. So the answer to this was like the normal projection, right? Because
yes.
just like remember it. It's the better if you remember it, but if I try to explain it a little bit. See, so this is the ground, which is ground in this case is Q, okay, and this is P. So if I'll light down a torch, okay, so then we will get like various sort of shades, and some portion will be here, okay. So we take this bit, okay, we take this bit which is P cosine theta. And how did we get it? We saw it with the help of trigonometry, okay. Now the point is, when we are saying normal projection, then we have to consider somewhat like a perpendicular thing or something like this, okay. All right. Now how this becomes like Q cosine theta, okay. Why is it Q cosine theta? It's part of mathematics portion, okay. So when we will study geometry in higher mathematics, or I don't know what is the term of that, then we will understand why normal projection of a particular thing changes into like Q cosine theta. Okay. So just for your understanding, it's just the way it changes. Okay. All right. But for the timing, just remember that normal projection, in case of normal projection, we are not using that particular object of which we are taking projection, rather the plane on which we are taking projection. Okay. All right. See, in this case, what was it? We had a stick of B, which magnitude is B. And whenever we were taking, and it makes a angle of theta with the plane on which we are taking the projection. On plane, along plane A or on plane A, we are taking the projection. And it makes an angle of theta. All right. And based on that, we are getting the projection of B to be B cosine theta. Okay. So based on that, it
Mm.
should have been P cosine theta, but as they have said the like a normal projection, that is why it changes. Okay. And why does it change? I mean, we will study that in mathematics. Okay. There is a particular theorem on that. Okay. Just for the time being, remember the terms. Okay. So that was it for the previous day. And now, okay. So cross products. So cross products, as we have already discussed, that cross products are the first vector times the second vector times sine alpha. And what is alpha? Alpha is the angle between A and B. Okay, alpha is the angle between A and B. And how do we get the like direction of the vector, direction of the resultant vector? It's by rotating from towards the second vector, from first vector towards the second vector, you will get the direction. And what was the rule of thumb here? Okay, say this is the first vector, this is the second vector. Okay, let's say A vector and say B vector. Okay, and I'm rotating in this direction. Okay, so first of all, the vector will be first vector cross second vector. You remember this one, right? The resultant vector.
Mm. Yes,
Okay. Yes. Now, what will be the direction of the resultant vector?
positive or anti-clockwise.
I mean, yes, anti-clockwise is a rotation. Okay, but because of the rotation, we will get a direction. Okay, which is either upwards or downwards.
Oh,
So, what is
upwards.
it? Upwards. In case of anti-clockwise, we get upwards direction. Okay, all right. So, this will be our
Yes.
direction for the R vector, and we represent this direction with the unit vector, which is eta cap. Eta cap. Okay, as you can see here as well, eta cap. Okay, right? Eta cap. All right. So now, let's see what's there. See, if the product of two vectors is a vector quantity, then that product is called vector or cross product. Very easy. The magnitude of the cross product is obtained by multiplying the magnitudes of the constituent vectors with the sign of the angle between them. Okay, so I've already said them. So R vector equals to P vector cross Q vector. It will equal to not PQ sine alpha. Why is not just PQ sine alpha? Because it is a vector quantity. That means we need a vector, and eta k cap is that unit vector which represents the direction of that vector. Okay, so eta cap is the vector here. Understand?
So eta cap
Mhm.
represents the direction of the vector quantity,
Yes, the resultant vector.
a resultant
Because
vector.
yes, because the previous vector's direction you already know that. So p vector's direction is known, q vector's direction is known. Okay, so you need the like the resultant vector's direction. Okay.
Yes.
Right. Okay. Hmm. Now let's see. So this is p vector and q vector, and eta cap is going upwards because the rotation is anti-clockwise, and the rotation is clockwise here. That is why it's going downwards. Now notice, let me explain one thing to you. So let us change the vectors to first and second to the second and first. So here q vector was the first vector and p vector was the second vector. Now let us change it, keeping all the vectors in the same position. P vector is the first vector and we are rotating from P to Q. Okay. So what will be the direction of the resultant vector now? It's going, the rotation is going
Upwards.
anti-clockwise, upwards, right? So that means we could say that P vector cross Q vector equals to minus Q vector cross P vector. What does this minus represent? This minus represents that the direction has changed from of the resultant vector from upwards to downwards. I think I have told this to you the previous day as well, right?
Yes.
Okay, good. And do you remember the right-handed screw rule?
What?
Say there was a like rule for, say for instance, if I'm rotating in this direction, say I am taking four fingers uh, and rotating like this, like the
Oh, the
palm of
confusion
my,
one, yeah.
okay. So and the thumb is going in the upwards direction. Okay, all right. Remember this. I think there's
Yes,
some better
I
visual representation
kind of don't
here.
want to.
Just a second, let me check. Um, might help you. Okay, I think I've lost. Okay, all right. Anyway, so I mean, just try to practice it at home as well because although you are like being able to just okay clockwise, anti-clockwise, upwards, downwards for the time being, but it's better for you to remember it because in the long run, when you try to learn physics, it will be very much important that you understand the right thumb rule. Okay, there is a another rule which is corkscrew rule, but that is like a little difficult and like 90% of our students use this rule, right-handed screw rule, but the corkscrew rule is a little difficult. Okay, but we will get into that as well. Okay, when we study like magnetism and all. Okay, anyway, so okay, I've already explained this to you why p vector cross q vector will be upward and q vector cross q vector p vector will be downward. Okay, all right.
Yes.
So now if alpha is equals to 0 degree, that is if the first vector and second vector is parallel to each other, then the I mean, what can I say? Resultant vector. There will be no resultant vector because it will be zero, right? In this case, the two vectors will be mutually parallel to each other. Okay, all right. So resultant vector. I mean, how can I explain this to you? See, if I take a cross product, say this is the p vector, and along this you are getting a q vector as well. Okay. So the angle is zero. Now cross product, by cross product we knew that there will be a sine angle between them. The angle between them is zero, right?
Yes.
Is that correct? So you will get the resultant vector's magnitude to be zero. Resultant vector's magnitude to be zero. Okay. And what is the direction you might ask? Okay, so direction, see, I mean, can you like see any rotation here?
No.
Get it downwards or upwards. So you won't be getting I mean it won't be upwards or downwards, but for like for the sake of like imagination, we could say that okay, if two vectors are acting in the same line, then the resultant should be at that line as well. Okay. Okay. But remember that was for our addition of vectors, but we are not doing any addition here. We are not doing addition here. Okay, we are doing cross products. Okay, so resultant is the different thing in this case. Okay, understand my point?
Yes.
It is not simply like p plus q equals to the resultant, so I call it okay, it will be somewhat like in that direction. It's not the case. Okay, so remember that. So if the questioner asks the question that if the angle is 0 degree between the first and second vector, then you will say that okay, we cannot get the cross product. Okay, as simple as it gets. Okay, the cross product's magnitude will be zero. Okay, and if you consider it to be a null vector, then there is no direction. Okay, is there any direction for null vector?
No.
Remember what was null vector?
One or the other. If
Null vector is a
two.
point, right? Just a point. Okay.
Oh, really?
And if
Oh,
we
it's
take
the null
two
factor.
opposite vectors of the same magnitude, we get a null vector. So here you get 5 Newton, here you will get 5 Newton. This point will be a null vector. Okay.
Yes.
And for 90 degree, you will get PQ. In this case, two vectors will be mutually perpendicular to each other. Obviously, you understand 90 degree means perpendicular. And if they are 180 degrees, that means they will be parallel and opposite to each other. Okay. So these are like very simple things. Let P vector and Q vector be the two vectors acting at O and making an angle of alpha. Okay, so they have developed a proof. So the adjacent sides of a parallelogram, then OA vector equals to P vector and OC vector equals to Q vector. Now from point C, they have drawn a normal. What was normal? Normal means a 90-degree angle, right? Remember?
Yes.
Perpendicular. The normal CD on OA. Area of the parallelogram is OA times CD. Okay, you know the formula for calculating the area of a parallelogram. So OA times OC sine alpha. How is it OC sine alpha? If we try to calculate from the little triangle, so it will be sine alpha equals to CD upon OC. So CD equals to OC sine alpha. All right. So then again, you will get this here OA times OC sine alpha, and then OA will be P times OC will be Q, and then sine alpha. So you get PQ sine alpha, which is P vector times Q vector. Okay, so now here we get a very important understanding here. Okay, are you done with taking notes of this? Just like
Yes.
draw a parallelogram real fast and just take a note of these lines. Obviously, the
Okay.
book is given to you. And you still didn't get the like digital version of your books, right?
No, I feel like that they'll give it to us at the end or at the start of next year.
Understand. Okay, in that case, do you have any chapter named dynamics in your physics textbook?
Let me go check.
Do you have it here now?
We have it with me right now. Yes.
Okay.
Oh my gosh.
Yeah, the books are very heavy.
Yeah. And I love taking them back, taking them all on the first day of school, all the way home.
How many pages are there? Like, is it greater than 1000 pages?
No, it's 500 and something.
500, right?
So it's not that heavy.
But it's there won't be like only one book, right? You will need more books because I
Yeah,
don't
yeah.
think the amount of
This is just
syllabus you
the
have to
first
cover
part.
is not enough for 500 pages.
Yeah, this
Okay.
is just the first part of the actual year.
Yes, yes.
What was the thing? Dynamics.
Yes, dynamics, yes.
We do have linear motion in waves slash force.
Okay.
Radiation, waves.
Haven't you studied
There's
waves previously?
yes, but we're just expanding it more upon that next year.
Okay, right. Understand. So do you have simple
Yes, and
harmonic motion as well?
sounds like a stand user. Simple. What was
Okay,
it?
just give me, I know it will be difficult for you to make a PDF. Just give me a PDF of the index, okay? At least I have to get the idea of what is being taught, okay?
Okay.
All right. All the sub chapters are included in the index as well, right? Like title of all the
Subtract.
sub chapters.
Yes.
Okay, all
Yes.
right. Okay, just give me a PDF by not, if not tonight, within 2 or 3 days, okay? All
Okay.
right. Okay, so all right, if you're done with this, are you done?
Uh. Oh, sure. Okay. Let me just do some little touch ups and everything.
Okay, all right. Let me know.
Done.
Okay. So now what I was saying is, see, we've already learned that cross product equals to first vector times second vector times the sine and angle between them, right?
Yes.
Now we also got here that we have already calculated the area of a parallelogram, right? We have calculated area of the
Yes.
parallelogram to get the cross product. Now, what that implies is that the area of a parallelogram formed by two vectors as adjacent sides is equal to the magnitude of vector product of the two vectors. So if like say for instance, if you are given two vectors, okay, which form a parallelogram, something like this, okay, you might not always need to calculate the say like magnitude, okay, p vectors magnitude and q vectors magnitude and so on. You might as well directly calculate the area of that parallelogram. Maybe there would be information given to you to calculate the area of the parallelogram, and you could say that okay, it will be the cross product of these two vectors. Okay, understand my point? And what will be the
Understand.
direction? Direction could either be upwards or either be downwards. Okay, understand?
Yes.
Okay, and we will learn about a matrix as well. uh, I think there should, yes, the matrix. Okay, all right, so now we've learned about the cross product of like two vectors, okay, in a say rectangular parallelogram, sorry, not rectangular parallelogram, only parallelogram, and it will be equals to pq sine alpha. All right, so now what about the unit vectors? Because always we are trying to work with the coordinates, okay, because it might be needed in the real world as well. So say ij and k are the unit vectors along x-axis, y-axis, and z-axis. That means if I take I cross I, it will be I times the I is the first vector and I is the second vector, and in between angle is 0 degree, right? Because they are working like parallelly or actually the same line, right? So that means it will be 0 degree. Is that correct?
Yes.
Okay. So I cross I, you will get 0. J cross J, you will get 0. K cross K, you will get 0. However,
So,
yes, go ahead.
so for scalar products, I cap times I cap equals 1, while
Mhm.
vector is I cap times I cap equals 0.
Yes. But don't say
Okay.
times because like it's not the time.
Oh,
Say I
I
dot
cap
I.
dot I cap. Yeah.
Yes, and in this case, you say I cap dot cross I cap. Okay, it's better. All right, now I cap cross J cap equals to they have taken like direction, and as you can see, sine 90 degrees there. Okay, because the angle between I and J is 90 degree. This is also 90 degree, and this is also 90 degree. All of them are 90 degrees. All right. So eventually we get a unit vector. So according to definition of eta vector, it is normal to both I cap and j cap. Okay. So positive z axis. Okay, why positive z axis? You will understand this. Yeah. See, I cap is the first vector and j cap is the second vector. So we are going in the anti-clockwise direction, right? Okay.
Yes.
So that is why it will go upwards, and that is what they have said as positive z-axis. Okay, along positive z-axis. It's like if you like draw a axis like x-axis and z-axis and put a pen like exactly upright at the O point, it will be our direction. Exactly upright at the O point. Okay, understand my point?
Yes.
Okay, like it's coming like outwards from your computer screen. Okay, that is what the direction is. All right, and okay, here's an important thing to understand. Have you read about cycles like cycle or circular series of like algebraic components, something like
I'm
that
not quite
in
sure. I
mathematics?
don't think so.
Okay, all right, you will read it then. So it's a very difficult thing actually to like solve maths, but the concept is really easy. So what is the concept? Nothing. Just it will have three components and they will form a cycle. Okay. So I, then comes J, and then comes K. Oh, sorry, second. I, then J, and then K, and then comes I. Now, what is the significance of this? Okay. From this circular pattern, okay, or circular series of pattern, you could understand the cross products. Okay. So from this, you can easily say that I vector cross j vector, sorry, I cap cross j cap equals to k cap. You could also say vector as well. J cap cross k cap equals to I cap. Okay. And k cap cross I cap equals to j cap. That means you will take cross product of two of them and you will get the other as the resultant. Okay. Now, what is the significance behind this? As we said previously, that if we take I cross j, we are getting the eta cap. Eta cap is the resultant, right? Because others value is 1. Eta cap is the resultant. You understand this, right? Be-
Yes.
Because others are 1. Unit vector, that means magnitude of others are 1. I, j, and k, all of it is 1. So now, eta cap, we are saying it's working in the direction of z axis. And obviously, along z axis, we had k cap, right? Is it correct?
Yes.
So that means that the cross product of I and j is k, right?
Yeah.
Cross product of I and j is k. Here it is eta cap, but eta cap equals to k cap because it is working along z axis.
Okay, this is getting confusing.
Okay, let me like
Too many
make it
caps.
easy for you. Say forget about caps and all. Okay, so this is the axis. Okay, forget that there is any z axis. Okay, so this is I. I mean, this is I cap. Actually, this is x axis can be I, and this is this along z cap. Now, if we work it along this way, we will get it like exactly maybe upwards or exactly outwards, you could say. Now, this could be represented by z axis, right? You have the idea of axis now. Okay, so you understand that this represents z axis, this direction.
Yes.
Understand my point? Okay, so along z axis, we have a unit vector called k cap. Okay, is it clear up until now?
Yes.
Okay,
Yes.
so now let us try to get the value for I cap cross j cap. So this will equal to I is magnitude, j is magnitude, and sine 90 degrees, right? And we
Yeah.
obviously need a unit vector, which is eta cap. We have already learned, which will show the direction only. Okay, now tell me, what is the magnitude of I cap?
Um, I cap.
No, what is the magnitude? Magnitude will be a value, like a simple
Oh,
value,
X.
just one, right? We have already said to be unit vector. Why is it named unit vector? Because its value is unit, one. Okay,
Okay.
right? You forget
Yes.
this. You cannot forget this. Okay,
I
one. Okay,
okay.
so 1 times 1. Then sine 90 is also 1. And then eta cap. Alright. So eventually we are getting eta cap. Now what is this eta cap? Eta cap is the direction. And the direction will be along the z axis. Already understood that, right? So can we not
Yes.
write it like k cap?
Um,
See, the direction is anti-clockwise. That means it will be upwards. Now what does upward mean? Okay. So keep your pen exactly upright on this point at your page wherever you have drawn this. Keep your pen exactly upright. Okay, did you do that?
sort of.
Okay, So that will be our direction of the cross product. Okay. Okay. And which is represented here by this. Again, let me show, I think, corner. Okay. Okay, this one would be better. You have to start visualizing these things, okay? Anyway, so this is the x-axis. This is the y-axis. Okay, x and y. Okay. So now we could either go and say this is I cap and this is j cap, right? This is j cap. So we are going in the anti-clockwise direction. All right. The image might be confusing. Consider it as anti-clockwise. Okay, you don't have to draw it. Let me just explain it to you. So if it is anti-clockwise, that means the direction will be along this plane. Okay.
Yeah.
So the three-dimensional image cannot be drawn here. Okay, that is why I'm showing it to you like this. Okay, but this will be the cross products direction. Okay, which we have said to be eta cap. Now, can we not replace this eta cap by k cap because it's going along the z axis?
Hmm.
Understanding my point? Because eta cap is a unit vector to show the direction. Okay, and the direction is along z axis. Okay, which is k cap. All right.
All right.
Is it still confusing? Let's think
No,
simply.
I have the idea. It's just like applications
Yes.
to it.
Application is very easy. That is what I am going to show it you now with the the chart or diagram, whatever you want to call it. So, okay, have you taken notes of this?
Yes.
Okay. So the application is the diagram that I've drawn. So very easy, okay. See, this is I, this is J, and this is K. So I, then J, J to K, and K to I. So here you will get three particular results. First of all, I cross J will be equal to K. Then J, because you have to go just anti-clockwise, okay, in this direction. If you change the direction, there will be a negative sign, okay? Why, you obviously understand that, right?
Yes.
Because the direction of the unit vector will change from upwards to downwards or from downwards to upwards, whatever you want to call it. And K cross I equals to J, okay? And also, if you change the direction, if you try to go clockwise, okay, so then it will be J cross I. Okay, sorry, I mean in this case we are going clockwise, and then if we try to go anti-clockwise, like changing the direction simply, so J cross I will be minus K, and then K cross J will be minus I, and then I cross K will be minus J. Okay, as simple as it gets. So that's about it. Okay, and don't get confused like the direction of here. It's just like a metaphorical representation to make you remember. Okay, in whichever the two of the vectors you will take as cross products, and the other one will be our result. Okay. Okay, let me know when you're done. And when we will do maths regarding this, the things will start to get a lot clearer. Okay, done?
Yes.
Okay. All right. So now comes the funny part, or like the
No,
part
no fun.
where we will get into the mess. Okay. Yeah, it's enjoyable. Okay. So
No
how do
fun.
we solve this math? Okay. A vector equals to I plus j plus k. And then B vector equals to 3i plus 3j plus 3k, showed that they are parallel to each other. So how can we calculate the um, cross product, that is? So you can get the magnitude of a vector. How can you get the magnitude? Tell me, what is the magnitude of a vector?
One.
How is that one? We read
Sorry,
it the
it's
day
not
before
in the
yesterday.
vector. Um,
How do you calculate the magnitude of a unit? I mean, what can I say? Three-dimensional unit vector, actually, or a vector in a three-dimensional coordinate system.
square root of I plus j plus k. Root of I squared.
Square root of i's coefficient squared plus j's coefficient squared plus k's coefficient squared. Okay,
Yes,
it's not
that
I
one.
plus j plus k, right?
Sorry.
Magnitude has to be a value. Okay, magnitude has to be a value. At least try to remember this, like specific terms. Okay, you cannot be forgetful uh, every single day. Okay, all right. So for b, it will be square root of 3 squared plus 3 squared plus 3 squared, right? Okay,
Yes.
all right. Although it won't be needed, but after like in some maths it will be needed. Okay, actually let me give another link. Okay, just a second.